The story of pi. Pi is associated with circles, so let us begin there. Take a circle. We call the perimeter of the circle as its circumference. Then we take the longest line passing through the circle, that is the line passing through the center, as its diameter. Now we have known for a very long time that the ratio between the circumference and the diameter is a constant. Now the proof of this is beyond the scope of this video, but we can convince ourselves with an experiment. Draw a circle with a compass. Since you have drawn it with a compass, you know the center of the circle. Now draw a diameter, that's any line passing through the center and touching the circle. Measure the diameter and keep it aside. Now here's the tricky part. Place pins all along the circumference of the circle. Take a piece of string and try to twine it as accurately as possible along these pins, and then snip it off. Measure the length of the string. It's a good approximation of the circumference. Then compute the ratio between the circumference and the diameter. No matter how many times you repeat it and for how many different circles you repeat it, you find the ratio almost tending to be the same. You can assume that in ideal conditions it would be the same. We call this constant as pi. Now what kind of number is pi? We need to be careful here because we often take pi as 22 by 7. 22 by 7 is a rational number. That is, it is the ratio of two whole numbers 22 and 7. If I were to represent 22 by 7 as a decimal, it would be 3.142857142857. That is, the pattern 142857 would keep repeating. It's a recurring decimal. However, pi is 3.1415926. It is a non-recurring decimal. So fundamentally, pi is an irrational number. So 22 by 7, 3.14, 355 by 113 are all rational approximations of pi. Now, pi is a real number because it exists on the real number line, somewhere around here. Now let us look at something interesting. Square root of 2 is irrational. Pi is irrational, but let's look at the difference between the two. If I were to represent root 2 on the number line, this is how I will do it. I'd measure the distance between 0 and 1, it is a 1 unit. Then I'll draw a perpendicular line of the same distance, that's another 1 unit. By Pythagoras theorem, I know that the length of the hypotenuse is square root 2. And then I'll measure that and represent it on the real number line. However, pi cannot be constructed. Hence, we call pi as transcendental. Square root of 10, cube root of 31 are non-transcendental yet irrational approximations of pi. So to sum up, pi is a real number because it can be represented on the real number line. Pi is an irrational number because it cannot be represented as the ratio of two natural numbers. And pi is transcendental because it cannot be constructed on the real number line with a ruler and compass. Now why the symbol pi? Contrary to popular belief that it is because of the sweet pie that's circular in shape, the symbol pi was used by the mathematician Euler extensively in his work, and that kind of stuck on in the literature that came after that. Now, how many digits of pi do we know? We have records from 2000 BC in Babylon that it was 3.25, and till today we are fascinated by the accurate value of pi. In India, for example, the necessity of astronomy and the precision of astronomical calculations led to pretty accurate values of pi. Like this since really the beginning of recorded history, with Archimedes, Euler, Leibniz, we have seen different ways to approximate the value of pi. Today, with the help of supercomputers, we know the value of pi to 13.3 trillion digits. Of course, we have no application, even quantum mechanical ones, which require the value of pi to such a precision. But I guess we humans tend to want to know more and push the boundaries of knowledge. In fact, we have Guinness World Records for the person who remembers the most number of digits, which is incidentally 70,000, recited in 9 hours and 27 minutes on March 21st, 2015. Now look at this symbol. This is a bit of fun. So may I have a large container of coffee? It's a mnemonic to remember the digits of pi. So the length of the word denotes a digit. There have been books, there have been poems that follow this scheme because of the fascination of the value of pi. So have a pi day, which incidentally is 14th March. That's 3/14. Thank you.